Hi, I'm Jeff Cogswell. Today here at Go Parallel, let's discuss atomic operations in threading building blocks. There are two main operations we'll look at and how they fit into atomic operations. The first is called compare and swap, and the second is called fetch and add. To understand why these are important, consider the situation of two threads trying to increment a variable at the same time. This is an exercise I've talked about many times here at Go Parallel, but I'll briefly restate it. The process of incrementing a variable can take three steps. Reading the current value, then adding 1 to the value, then saving the value back into the variable. If two threads are trying to do this at the same time, they might trample over each other. With both threads reading the same first value, incrementing, and then both writing the same value. So the end result is the counter only goes up by 1 instead of 2. There are a few different ways around the situation, such as using critical sections and mutexes, but those are both expensive solutions in terms of processor time and operating system time. So another solution is a lock-free approach. Threading building blocks lets you perform some basic operations such as an addition or increment such that they happen atomically without other threads interrupting the process. And there are actually CPU level instructions that can accomplish these, and TBB can take advantage of them when they're available. So TBB includes an atomic template. Let's go find this. I'm at the documentation in threading building blocks. I'm going to open up user guide and design patterns. And I'm going to go down to atomic operations and scroll down, and here they are. TBB includes an atomic template that supports these 5 operations, and the first 2 are just a read and write operation. Just read the value of x and write the value of x and return it. And after that we've got fetch and store, and fetch and add, and compare and swap. First I'm going to look at fetch and add, since that does exactly what we were talking about earlier. First it fetches the value stored in memory, then it adds onto that value the number you provide, and then it saves the final value back into memory. It does those steps as a single atomic operation without other threads walking over it. And then we've got fetch and store. This one is a little simpler. It simply stores a new value into the variable while giving you back the value that was previously stored in the variable. And again, this happens as an atomic operation. It has to, because you want to read the current value and replace it without some other thread throwing in some other value and expecting that value to stick. And then finally we've got compare and swap. The idea behind compare and swap is that your code will first check a variable's current value. You'll save the current value aside into another variable. Then you'll do some work on that value, whatever your program needs to do. And finally, you'll try to store the new value back into the variable. But before you store it, you want to check if the variable still has the value it had when you started. And you do that by comparing it to what you saved aside. And if so, then you can proceed with the store. If not, that means another thread at some point in there also grabbed the original value and did some work on the variable and saved it back in. So now it's up to you to proceed how you want to handle that situation if that indeed happens. The key here though is that one little part where you check the value and compare it to the new value you stored away. If it's the same, then you save your new value in. That's the compare and swap operation. And it can be reduced to a single atomic operation. So before I wrap this up, I need to mention that the compare and swap has a potential pitfall. There are situations where the value you're looking at, which appears to be the same, could actually have changed. For example, it might represent a pointer inside a linked list, and another thread may have changed the linked list, and to your thread it appears everything's the same, but in fact things are not the same. That's called the ABA problem, and I'm not going to cover that right here in the video, but you can Google it and learn more about it. So that's it. Take a look at this documentation, and also in my blog here on Go Parallel for examples on how to use this template in threading building blocks.